What is the most difficult and strangest molecule to study on Earth? The answer to this question might surprise you because it's water. This seemingly ordinary molecule that surrounds us everywhere is in fact anything but ordinary. Think about the ice that floats on top of Cayuga Lake. For any ordinary substance, its solid form should be denser than its liquid. Yet water, the ice, floats on top of its liquid form. So why is water so strange? Part of my thesis really has been trying to understand these questions, and I tried to look for the answer in supercooled water. What is a supercooled water? The regular water freezes at 0 degrees Celsius, but if you can carefully filter it to be extremely clean, free of any particles, you can delay its freezing by 40 degrees Celsius. So between 0 and -4, the liquid that exists there, we call it supercooled water. What does it mean? It means in a clean world, you could be having a rainy winter in Ithaca instead of snowy one, or the spring for that matter. So why is supercooled water special? The scientists have discovered that there is a clue that's hidden in supercooled water that could really explain why water is so strange. Why does ice float on top of liquid? However, unfortunately, all this evidence that people have theoretically pursued is hidden in this region called the no man's land, where accessing liquid water has been impossible to mankind experimentally. So what does an experimentalist like myself do? Do we give up? Do we give up chasing the question of why water is so strange? I wonder what happens if I take a blurb of a vapor that's 100% humid in air, in water, and then bring it to this temperature. At room temperature, you can imagine that it will form a dew, it will condense to a dew. Below 0, I assume that it will be a frost. What I found in the lab instead was that before forming a frost, it always had to form a dew first, which then freezes into the liquid, the ice. Meaning that this intermediate stable liquid always exists in this temperature. Thank you.